Can't always get what you want.
Okay, I'm going to get started now. Hello, everybody, and welcome to our webinar, COVID-19, Climate Change and Politics. You are in for a treat and some new ideas and thinking. We have many guests today from all over the world who've not joined us before. Very briefly, I want to encourage our guests to join the World Medical Association Associate Membership. Associate membership is the way individuals can join the WMA, the biggest bargain in organized medicine. The benefits are opportunities to learn about WMA policy development, to comment on proposed policy and introduce new policy, to participate in webinars and virtual and in-person meetings, and most importantly, to develop international relationships and friendships with the most interesting, innovative, caring people from diverse cultures all over the world. It's easy and inexpensive. You just go to the website at wma.net and click on Join Us in the upper right corner. We're recording this session today. Please feel free to send any questions through the questions section of the participant tab, and we'll get to as many questions as we can after the presentations. Now, it's with great pride and great pleasure that I introduce our keynote speaker, Dr. Aaron Bernstein. You've seen his CV online with the announcement for this seminar, so I will just briefly say he's a well-known author, advocate, teacher, television pundit, essayist, and expert on the effects of climate change. And he's interim director of the Center for Climate, Health, and the Global Environment at the Harvard T.H. Chan School of Public Health, which is known as C-Change, Harvard Chan C-Change. So Dr. Bernstein, it's all yours.
Thank you, Joe, and I am deeply grateful for the opportunity to speak today. And I think, Peter, were you going to give some opening remarks, or should I dive in?
You should dive in.
I will dive in. Okay. So, welcome everyone, and I would like to take the next little while and leave lots of room for questions to give some thoughts about the intersection of the current pandemic, COVID-19, climate change, and politics, and the particular meaning of politics. In this case, I'm talking about how we get things done in society rather than partisanism, although that certainly plays a challenge regardless of where we are in the world. Oops, I did not want to do that button. I have no disclosures to make. So I'll start by making the claim that when I used to think about climate actions, things that reduce the emission of greenhouse gases, I used to think that when we did those things, like transition from burning coal and gas to make electricity, we would have cleaner air. And that would mean there are fewer heart attacks, fewer strokes, better birth outcomes, and fewer people dying before they should. I thought we would have healthier diets because plant-based diets produce less carbon emissions. They also tend to be less disease prone, and that would result in fewer heart attacks, less strokes, diabetes, you all know this. Healthier body weights because we might be, for example, bicycling and walking more and sitting in cars less, using public transportation more because decarbonization involves some means of changing transportation systems. That has huge health benefits, of course. There are other things that sometimes aren't as immediately apparent. We might have lower utility bills. It turns out that On the one hand, things like greening cities, where you plant trees actually can lower utility bills. Green roofs can lower utility bills. These are things that reduce urban heat island. They also, of course, absorb carbon, and higher utility bills promotes housing insecurity, which, as I'm sure everyone on this webinar knows, is a major factor in worse health outcomes. Then, of course, if we in fact priced electricity, as one example, based upon its true cost, including its carbon costs, not to mention the air pollution costs, the current costs of providing utilities, electrical in particular, to homes and businesses would be way higher than it is now, and renewable energy would be in fact much less expensive. And in many places around the world, these days, many governments have actually started pushing on that so that people can get, for example, solar in their homes and pay no electricity bill, and in fact, in some cases, even make money. So lower utility bills. And perhaps most compelling in many ways is that all of these actions that I've mentioned have benefits that accrue more to people who have been left behind. So the air pollution, the unhealthy diets, the poverty that has come in the United States, for example, with structural racism, and therefore more housing insecurity, that these climate actions are actually actions that promote inequity. So there was a pretty good case to be made that climate actions were really good to deal with problems that are really big when it comes to health. And to illustrate that, we can just look at the global burden of disease. So this is a map of the disability adjusted life years, so measures of morbidity, how much ill health, various diseases in the world. This is global cause. And you can see I numbered the top 10 sources of disability adjusted life years. And the question is, which one of these wouldn't get better with climate action? Now, you all should be taking notes and you can ask me, but I'll tell you that all of these will get better, including number 9, congenital defects. We know that heat, for example, is a risk factor for congenital birth defects. Air pollution is a problem for congenital birth defects. So every single one of the top 10 global burden of diseases are going to get better with climate action. Now, what's interesting about this is that many of these diseases have been really hard to deal with using a standard medical model. The classic example being obesity, right? So, you know, a large share of heart disease, stroke, diabetes is a result of obesity. And, you know, going to a doctor's office for obesity has not been shown to be a particularly effective intervention, but addressing the root causes of climate change could be. And so not only do we have a chance with climate action to address a whole suite of major disease burdens, we have an opportunity to get at some diseases that have been particularly hard to get at through standard medical interventions like obesity. The other point that I will stress again is that air pollution in particular is not an equal opportunity killer. So just to dig onto the injustice piece, this is data from the United States, but it's similar to data you could find in many countries around the world. And it looks kind of messy, but what this is showing is that between Blacks, Hispanics, and whites in the United States, you can look at the amount of air pollution that these particular groups are responsible for. That's the caused column. And you can look at the amount of air pollution they're exposed to, which is the exposed column. And you can see here that Blacks are exposed to the most on average, Hispanics slightly less, and whites the least. But if you look at the amount that each group is responsible for, you'll see an even more jarring disconnect, which is that Hispanics and Blacks have the least responsibility for the air pollution that they are most responsible for. And if you look at the categories in the sort of rainbow of colors on the right here, you'll see that, you know, industrial emissions are a huge part of emissions, right? Fuel emissions are a big part of the emissions here. And so if we get rid of those, we will in fact rectify some of the injustice. And this isn't just about the exposure, just to be clear. This is about mortality. This is some of the most recent evidence on that front, a study from colleagues of mine at the Harvard Chan School that looked at air pollution in the Medicare population in the United States. And what's alarming here is that while there are disparities between, for example, Native Americans, Hispanics, and everybody else, Black Americans are way more at risk than everybody else for dying from air pollution in the United States. And that's, again, regardless of their eligibility for Medicaid. So it's not just poor Blacks in the United States. And so we see that climate actions can make a difference within the country. There's another angle to equity and climate that is critical, which is this. I call this the exported exposure problem. And what these graphs show you is that by people, for example, in the United States, buying goods and services that are produced in China, we are in fact outsourcing our pollution. So a lot of the industrial production used to be in the United States, but it is no longer. It is largely happening in Asia. And that means that every time we buy something here in the United States, it produces pollution elsewhere. And this was a study just recently published in Nature showing that, for instance, deaths outside Western Europe were large. Interestingly, the Western Europe was responsible for more displaced mortality than the United States, and that's because of where their production is relative to where people are. But of course, China overall is suffering the greatest problem from goods being shipped out of its borders and pollution being sourced within. And so again, most of this mortality is being driven by the burning of fossil fuels and getting industry in particular to reduce use of fossil fuels, which is by no means an easy task, but not an impossible one, can go a long way to reducing this inequality. So we see inequality at several scales that's potentially in play here. We see racial inequality, we see transnational inequality that matters. And then it gets even more interesting. So you take the data in the United States I showed you about, for example, the risks of African Americans, Black Americans dying from air pollution. And then the emerging research, including this paper, again, done by colleagues of mine at the Chan School, including Xiao Wu, Rachel Nethery, and Francesca Dominici, where they looked at long-term air pollution. So air pollution exposure in counties across the United States over a decade or more, and tried to figure out whether that long-term air pollution exposure put people at greater risk of dying from coronavirus. And what they found is that a 1 microgram per meter cubed increase in particulate matter exposure increased the death rate by 8% as a best estimate. And that's accounting for other factors that would explain whether or not people are dying from coronavirus, including things like obesity, access to care, smoking status, population density, a whole host of things. And the finding was robust to multiple sensitivity analyses. And then we see data like this, which is quite alarming, which is that not everyone is dying equally from coronavirus. So we see African Americans, Black Americans having the greatest risk, indigenous populations right up there, Latinos. And so it begs the question whether some contribution to the disparate outcomes from COVID are being driven by historical exposures to air pollution. So I gave you that long list of ways in which had historically thought that climate actions could benefit health. And now with this data, one has to start wonder whether addressing climate change might in fact improve outcomes for things like coronavirus. Now, it's not going to matter necessarily right now, although of course, as you all know, air pollution levels dropped around the world as economies shut down. And of course, there were health benefits to that. But the benefits of reducing air pollution are going to matter not just to this, they're going to matter to influenza. There's a robust amount of information about air pollution, particulate matter air pollution, and influenza outcomes. And so we're now forced into a framework that's potentially even broader than the one I originally proposed, which is that maybe climate actions are actually pandemic prevention actions. I think it's important to note that the inequities of air pollution are not limited to particulate matter. They also extend into carbon emissions themselves, right? So the reality is that the people who are putting out the most carbon emissions are likely to suffer the least from the adverse effects of climate change. So there's an additional aspect of equity here that goes beyond the near-term effects of air pollution or even the decadal effects of air pollution to the long-term effects of climate change. So I hope that sets the stage for my remarks, right? So there's a whole suite of benefits we have from climate change. And the question is whether climate actions really can matter to dealing with things like pandemics. And I think in the narrow lens of air pollution, that's probably true. And that there's a whole suite of equity outcomes that come with that. So let's take this on. Let's see if we can think about whether there are pathways through which climate actions can affect the spillover of disease. So the pathogen, in this case a virus, moving as we expect it did from a bat, maybe, although it's uncertain, sometimes pathogens move from bats through livestock to people, but in any event, ultimately from a bat to a person. So to think about that question, we need to take a moment to think about how diseases like COVID start, right? So once the disease is out, like COVID, and it's spread through respiratory pathways, we know that air pollution is probably going to matter to outcomes. But I want to take a step back and say, well, what about the origins of these diseases? How do these diseases get into people? What are the things that are driving them? And does climate action matter to those as well? So at a very high level, there are a few forces that are driving these outbreaks. And so we have chopping down trees, particularly deforestation, and essentially land use change more broadly. That could be, whether it's a forest or a savanna or whatever, being cleared for agriculture, which is the largest driver of this right now. Consumption of wildlife. So people consume wildlife for subsistence. That's probably how diseases like HIV emerged, Ebola, probably, and then wildlife trade. So these are, the wildlife trade, we don't really have a very good handle on its scope, although we know it's big because a large share of it is in the illegal wildlife trade. We have absolutely no real tallies of that. But this is a multi-billion-dollar industry in the legal pet trade, wildlife trade. And that sends people into forests, into natural, wilderness, harvesting animals, bringing them into close contact with other animals, often in close quarters. Now, there are other drivers of zoonotic disease emergence, to be sure, but these are three of the big ones. And what happens when humans come into contact with animals, particularly wild animals, but also, of course, domestic animals, is that they can come into contact with pathogens. And this is a cartoon that sort of illustrates how this can happen. So whether it's a bat, a rodent, or a primate, they can come into contact with livestock or people. That happens every now and again. That's the sort of tan-colored wave on the bottom that there's spillover of pathogen either into domestic animals or into people. And that happens every now and again, but it doesn't usually lead to an outbreak in people of any size. But every once in a while it does. You can kind of think about it like a game of roulette, which is you're throwing a marble into a spinning wheel, and every once in a while you supposedly get lucky, but that's more or less the process of spillover and the risk of disease emergence. It's really important to remember that when humans come into contact with animals, that those animals are swimming in a common germ pool with us. Particularly in medical education, one might get the impression that there are pathogens of people and there are pathogens of animals, or maybe just frankly that there are pathogens of people. I mean, what do we really learn about pathogens of animals in medical school? Unless you're talking about very specific pathogens that might, come out from livestock in particular. But it turns out, of course, that for pretty much every known human pathogen, that pathogen probably either has a host that is non-human, like influenza, or it has a first cousin that infects the animals. So whether it's measles, which came from ruminants into people, or HIV, which came from non-human primates, smallpox has various pox viruses, cowpox, camelpox, monkeypox. That these pathogens of animals are more or less the same as people, and particularly when it comes to viruses, which are the largest share of these emerging infections, we see ample numbers of viruses, and best estimates are well over 1 million viruses that are potentially out in animals. We really don't have a good sense as to what the potential of those viruses is to infect people, but the interesting data point is that we see an increasing trend in the spillover and outbreaks of pathogens into people, which is what I'm showing here. The bars represent different kinds of emerging infections. The zoonotic diseases coming from wildlife, which is the biggest source, is the white bars. Non-wildlife emergence is the darker orange bars. The black bars are non-zoonotic diseases. Those are mostly antimicrobial resistant infections, and the large increase in the 80s was due to HIV. So all of the resistant pathogens that emerged in the 80s with the advent of HIV. But overall, the signal is increasing, and the number of events is mostly being driven by spillover of pathogens from wildlife into people. Now, this shouldn't come as a great surprise to anyone who's been paying attention to what's been going on in nature. We are losing species right now, today, at this very moment, at a rate that has not been seen in 65 million years. That's when the dinosaurs and half of all species on Earth went extinct. That was caused by an asteroid hitting the Gulf of Mexico, essentially shutting off photosynthesis to the planet for a period of time and causing a mass die-off of species. Of course, there is no asteroid hitting the Earth right now, but there are human activities that are driving the loss of species and biodiversity more broadly. And those same activities are driving disease emergence. So if you look at emerging infectious diseases, since 1940, about half of those emerging diseases have resulted from land use change, which is primarily deforestation, agricultural changes, and number one cause of deforestation is agriculture, and food production practices, particularly the concentration of livestock into dense quarters. So you see that there are large forces that come from destroying nature or wildlife trade. And what's interesting is these days, wildlife trade has moved into agricultural practice. So there are huge farms of wildlife which are essentially domesticated for the purposes of, for example, furs and coats, for medicinal purposes. So we're no longer just hunting the animals individuals and selling the small scale, we're actually cultivating these animals. That's, for example, a part of the root cause of SARS. SARS was amplified likely in some civet farms. So the big picture here is we're really changing the composition of life on Earth. That is a major force in driving disease emergence, and deforestation in particular has a big part in that. Now, I hear you cry, wait a minute, what about travel? After all, we're traveling more than ever. This is a snapshot of flights. This is from 6 years ago now, where there were about 58,000 flights every day in the world. And doesn't travel by plane and the growing urban population really matter to the movement of these diseases? And the answer is, of course it does, absolutely. But you wouldn't have the potential for pandemics without spillover. So if we weren't, in fact, moving into nature and taking out nature and coming into contact with animals in the first place, it really wouldn't matter as much how much we travel or how dense our cities were. And the argument that is we should prevent a further pandemic by restricting air travel and keeping people from moving to cities strikes me as a particularly difficult charge in the scope of the way people expect societies to work, and for that matter, for economic opportunity. So I tend to think of, travel and population density in cities as a sort of, pouring fuel on the fire that's lit by spillover. And all this is to say that you're not going to prevent pandemics by preventing air travel. You really have to think about preventing pandemics at their source, which is spillover. And that very much has to do with addressing changing of nature, or deforestation in particular. That means addressing the wildlife trade, and to the extent that it is possible, addressing subsistence consumption of wildlife, particularly in areas where population growth is happening quickly. So we did a sort of thought experiment, which we published a few weeks ago in Science, which said, okay, so if we know where these diseases are coming from, and we know the actions we need to take to prevent disease emergence, what would they cost? So we looked at a suite of actions. We said, let's reduce deforestation by half in the top emerging infectious disease hotspots, so the places where we see these diseases emerging, where the deforestation rates are happening, populations are encroaching. Let's spend enough money to monitor for spillover. So we need veterinarians, we need better disease surveillance in populations at risk, whether that's in the livestock industry, whether that's in the wildlife trade. We need more money focused on wildlife enforcement. So we estimated that those actions would cost $22 to $31 billion a year. And that seems like a lot of money, and it is a lot of money. Rarely have measures been enacted at this scale, certainly in the realm of conservation. Now, the United States spends many trillion dollars a year on healthcare alone. So in the context of what we're spending to take care of ourselves after we get sick already, regardless of COVID, this is not a small amount. This is not a large amount in the United States. But then, of course, you look at the cost of coronavirus to the world, and we're looking at $10 trillion. So the question becomes, we know what we need to do. We know it's cheap. Our salvation comes cheaply, and yet we don't really spend the money. If you look at what we talked about, so wildlife trade right now, we probably, our best estimate is that about $260 million are spent to monitor the wildlife trade for infections. And that's being generous. There's about $20 billion spent globally on all protected areas. That's all national parks and preserves and these sorts of things. But only about $2 billion of that is on preventing deforestation. And then about $3 billion is spent on spillover detection. And that's also a generous estimate. So, we're not spending really anywhere what we need to spend in these areas, particularly on wildlife trade. In the realm of climate change, we're also not spending anywhere close to what we need to spend. So our most recent estimate is about $580 billion are being spent on climate finance. Some of that is going to accelerate mitigation activities, things that are going to reduce our reliance on fossil fuels, decrease carbon emissions. Some of that's being spent on building resiliency to climate change, figuring out better ways to grow food, protect water supplies, these sorts of things. The IPCC, in its 1.5 degrees C report, which was the report that said what would be the gains if we limited warming from climate change to 1.5 degrees Celsius instead of 2 degrees Celsius, estimated that we'd need to spend about $1.6 to $3.8 trillion. So we are wildly out of tune with the climate investment needed. So all this begs the question of why can't we in fact do this? Why is it that we have clear evidence about what can prevent pandemics? We have clear evidence of what's at stake for our health when it comes to climate change, and for that matter, the near-term effects of fossil fuel use, and we're not spending the money. But yet we'll shell out $10 trillion after the fact and to pick up the pieces. And of course, there's nothing written about the reality that another pathogen like COVID-19 could emerge. And you remember it's COVID-19 because there was a COVID-03, which was SARS. That was, same story, bats carrying of coronavirus. We also had MERS, the Middle East Respiratory Syndrome, that emerged 4 years ago. So there's now been 3 newly emerged coronaviruses, each more damaging than the next. And so there's nothing written that another coronavirus, or for that matter, another virus could emerge. And HIV, as another example, costs roughly $30 billion a year to the world in costs. So we're spending lots of money every year to deal with these things. And so I think that gets into the last point I'll make, which is the politics of this. I don't have slides on this, but I just want to raise a couple of points. It's pretty clear that when people see a health crisis like COVID-19, we're very eager to throw money at the problem, even when it may not be very effective. And so one thing I've been asked many times in the past few months is, how do you relate COVID-19 to climate change? And I said, well, COVID-19 teaches us something, which is that when people perceive an imminent risk to their health, they're very eager to do something about it. The challenge then becomes, are we going to do something about it that actually is wise and evidence-based and effective versus throwing money at a problem in ways that are in fact not particularly helpful? But nonetheless, people really want to do something when something is seen as imminent and a personal threat to their health. Climate change, since it was first identified in the public consciousness around the world, has been framed as a problem for the future, and polar bears and icebergs. And these are the images that are conjured up in people's mind. And even if it's considered a direct human health risk, it is a health risk for somebody else, and probably still in the future. So the politics of climate change have been distorted, for sure, around the world, particularly by interests that want to preserve the status quo, and with good reason. You know, as one example, fossil fuels are responsible for 80% of greenhouse gas emissions, and that means they are a huge part of the global economy. So the idea that that just vanishes and it doesn't cause enormous problems is at best naive and at worst dangerous. And I think a major problem of the politics of climate change is the need to better address the interests of particularly the people who are not running the fossil fuel or other fossil fuel-based industries, but the people who are employed in those industries, because in many cases, those individuals have limited to no other opportunity to make a livelihood. And to simply suggest that we will move from fossil fuels to renewables or nuclear or whatever else as just in the electricity space, without recognizing that and grappling with that, is a setup for a non-starter, and understandably so. So the two pieces I see as critical, as I've just outlined, is one, we need to recognize that climate change is very much a here and now problem, and not necessarily because of the effects of greenhouse gases, although of course, you know, with the western half of the United States and large parts of the world baking this summer, the evidence is clear that climate change is affecting health right now. The challenge is that you have a hard time, as anyone who practices medicine will know, convincing someone to stop smoking if you tell them, well, you can stop smoking, but you're still going to die of lung cancer, right? What really matters is the potential that your actions benefit you in your own lifetime, that you can see the positive effects in the near term. And that's why talking about what are, I think, mistakenly called the co-benefits of climate action is critical. And I say it's a mistake to call them co-benefits because to everybody else except those passionate about climate change, the concerns are not about 100 years from now or 50 years from now. They're about right now. So the real benefits to everybody who's not in climate change are the reality that if you stop burning, if you stop producing air pollution, you might not get pneumonia. You might not die of coronavirus. You might, in fact, lead a healthier life if your body weight were, you know, better. So we've put the cart before the horse. We've talked about very important things as relates to the stability of the climate and the natural systems that I would be the first to say our life depends on. But in my view, we are not speaking to the needs and interests of everybody else. And then the second issue is we need to specifically think about the reality that the actions that are needed to address climate change are very threatening to huge numbers of people who have done nothing but make, for example, this webinar possible by ensuring that the fossil fuels that are mined, transported, refined, burned, disposed of, et cetera, et cetera, et cetera, they are doing us a great service, and to act as if they've done otherwise is a surefire way to make sure that we don't get to where we need to go. So the politics here are not easy, but I think there is a path forward that we need to grab onto, particularly now when we see so much investments in recovery. You know, there was just an analysis out this week that showed that, for example, in those stimulus funds from the European Union, about 20% of those funds are going to advanced climate solutions, which, as I mentioned, are potentially pandemic solutions, as well as equity solutions. The United States, we're closer to 1%, and there's a range in between. But there are real opportunities here to steer investments in ways that can promote health right now, that will address climate change, that can promote equity, and potentially reduce both the burden of potential pandemics and their emergence, because after all, preventing deforestation is a cornerstone of climate action. Maybe 15% or so of carbon emissions come from chopping down trees in tropical regions in particular. I hope you found that thought-provoking. I'm going to stop here and look forward to taking your questions.
Thanks so much, Dr. Bernstein. That was great. Before we take questions, it's with great respect and gratitude that I now get to introduce Dr. Peter Orris, whose curriculum vitae was also online. Dr. Orris is the professor and chief of occupational and environmental medicine for the University of Illinois Hospital and Health Sciences Systems. He has a long international reputation of working within medicine against climate change and racism, and is known to all the international health agencies. He's a remarkable, caring guy who's well respected within the WMA, especially by our junior doctors, for being a wonderful role model and caring advisor. He's co-chair of our Climate Caucus. And Peter, would you like to make some comments?
Thank you, Joe. Thank you. Actually, after that introduction, I best not say anything because I'm not going to do better than that extraordinary introduction, so I appreciate it. Let me just throw in a couple of cats amongst the canaries, if I can, to further stimulate the discussion. The first is on a question that I never quite focused on before in this as part of the analysis. And actually, I looked on the Q&A, and my colleague, Susan Buchanan here at the University of Illinois, had the same initial concern. This is a 10,000-foot concern and a lack of understanding of mine. I understand when we are discussing deforestation and destruction of natural habitats for wild animals, that there is pressure on those animals to come in closer contact with humans. The whole concept of wolves in New York City is the classic setting, if you will. And I see that as part of the pressure for this spillover. But if we are destroying the number of species that we are destroying now, in other words, there's a period that there's the pressure, but then those wild animals are destroyed within the process. I'm not clear how the destruction of those species is a pressure for more spillover, rather than pressure for less. It's a little like us not traveling in the current pandemic and therefore the air pollution improving considerably. So that's a theoretical question that I leave on Dr. Bernstein's desk, hopefully to explain to me. Let me then go to the next step. And that is, I think it is critically important to take this analysis and to take this really exciting presentation and conceptual approach here from a classically medical but public health point of view to the next step, which is the political point of view. And that is, if we use as an example the recent Harvard study about the confluence of deaths related to the pandemic and the air pollution factors that were cited. The one factor that they didn't build in here is the government's commitment in those areas toward the social programs to ameliorate some of the structural racism and division in the country economically, etc. And I think that's because we as public health people have a real hesitation of making that last jump. We're afraid that we are going to alienate sections of the population that we can talk to if we stick purely to the public health arguments. And I would argue here that it is so critically important that we make the totality of the analysis of the social programs of the political structure and of the political leadership, that this overcomes that fear. At least we need to move in that way for some of us, so that we take it and let's say on that Harvard study, let's take it to the next step. And we don't have to talk about partisan politics. We can talk about what were the government social programs in these different parts of the country to ameliorate these underlying problems that we all know have amplified the impact of the pandemic on Black and Latinx and other minority and deprived communities. So that would be, I'd really be excited to see that from coming out. The next step is, if we apply that internationally, obviously that has a real significant application and an immediate application within the next 8 weeks in the United States. But if we apply that internationally, I think we lack data now, but the data is becoming clearer that countries that there are 2 factors in how significant this pandemic has been with respect to morbidity and mortality. One factor is certainly those poor countries with the least ability to cope with just such a pandemic are in general suffering much worse effects. This is true for climate change and global air pollution, et cetera, as well, of course. And they're interrelated, as Dr. Bernstein has indicated this morning. But I think in addition to that, the social policies of governments across the political spectrum and across the world reflects those outlying countries, poor countries that have had a minimal effect of the pandemic, often due to the social mobilization in that country because of the support of the government with respect to reliance on science and mobilization of the people at base levels. And countries that should have all of the resources necessary to be able to cope and reduce the overall exposure and morbidity mortality, and so blatantly have not done it until starkly up against the wall of the impossibility of continuing in the current way. And this applies to Europe as well as a number of other countries, and classically with respect to the United States. Now, within the United States, obviously there's a historical, cultural tradition of go it your own, don't pay attention to what the central government says or even your local governments. Having recognized that, there are periods of time in our history where one has been able to mobilize the public as a whole, and areas of the country that has gone on. And that is a twin historical, cultural history, I believe. From this point of view, I think that will be a very interesting data as it comes in and it applies to Western Europe, applies to Scandinavia and other countries, and will be important lessons to teach us. And then finally, my only other comment would be the importance of the health sector and health professionals within that sector to make the arguments that you are making, Ari, this morning about what is the reality and what are the interconnections. And that can't be restricted to those of us interested in environmental issues or public health issues in general, has to be transmitted by our clinical colleagues that spend most of their time treating individuals on a global level. And our clinical colleagues will mobilize best, I would postulate, when they themselves are convinced and change their own behavior with respect to climate and a variety of other risk factors here. The kinds of things, as Joe mentions, that, for instance, Healthcare Without Harm and other groups within the health sector have been agitating for, so that the health sector as a whole, including clinicians and public health people, can speak about intervening, changing our own behavior to reduce our carbon footprint, and moving ahead as role models for the rest of society. I hope that stimulates a good deal of controversy, and I leave it with you. And I thank you, Joe, very much for allowing me to comment on Ari's really exciting presentation this morning.
Ari, do you want to respond at all? You're muted.
In an effort to
You're
keep,
muted, Ari. There you
I
go.
got it. So I should probably address at least one point there, because mostly I agree with what Peter said. But one of the first things he talked about was the sort of question around, the reduction in species is not necessarily clearly, how does that actually relate to disease emergence? Because after all, if there were no other species on Earth, then there would probably be not a lot of disease emergence. And I think that's true. So there's two things. One is that I oversimplified the issue of biodiversity and put it in terms of species loss. So biodiversity is more than just species counts. We use species counts because that's the data we have mostly. But any clinician knows that biodiversity really matters at the genetic level, because the difference between MRSA and MSSA is a genetic diversity issue, not a species diversity issue. It's also true that biodiversity operates at an ecological level. So an ecosystem being the constellation of species operating in a specified, geographic area. You can't recreate a rainforest in New England. It's not going to work. And so, even though there are many species that are widely geographically distributed, and not because people have introduced them, their function, their role differs based upon where in the world they operate. And so the loss of biodiversity is a marker of humans mucking with nature. So species loss is a marker. So you could, for example, as has been done in New England, there's people always say, well, there's way more trees in New England today than there were, when just in the colonial period of the United States. That's entirely true, but the biodiversity is in fact far less. And that loss of biodiversity actually is probably a major factor in the reason we have so much Lyme disease. So I think the issue is, well, the evidence here, particularly in the tropics where most diseases emerge, is that there appears to be a point at which the paradigm shifts. So, I would say the data is pretty early here, but it seems that, when you in a tropical forest like in the Amazon, if you increase the forest edge to roughly 50%, so that's not necessarily losing half the forest, that's like increasing the edge distance of the forest by cutting into it or creating roads or whatever, that may be the optimum for human engagement with wildlife. Now, you may not have lost a single species in that process, but you've interfered with that ecosystem in a major way. And so you see the risk, and particularly this is of the vector-borne diseases. In South America, that could be a whole suite of them. That tends to maximize at around there, but I'm sure it's different in other parts of the world as well. So I think the connection is about biodiversity as a holistic concept. I think species declines is a marker of the extent to which people have engaged with biodiversity and messed with it. It's a fairly late indicator, right? So lots of things go wrong before a species gets wiped out. But it is not a fantastic metric of risk of disease emergence by any stretch, because we don't species loss, because we don't really have particularly robust measures that you can track like species in the context of ecosystem function, as an example. There was another question asked about connecting deforestation and disease emergence. So there's a whole bunch of literature, and you can look at the Science article I cited. We cite some of those papers, but there's very good evidence now that the most recent Ebola outbreak was driven by deforestation. There have been many Ebola outbreaks in Central and Western Africa, but the most, well, not actually even, we have another one, but the relatively large one that happened in 2013, 2014, that loss of forest in equatorial Africa pushed bat populations into places they hadn't been before, which turned out to be much more connected to places like Guinea. And the roads in particular got what was an emergence event in a remote part of that part of Africa into a major population center, which was Conakry. So, and the other issue, of course, is that Conakry's population has like grown tenfold in the past 30 or 40 years. So you have more roads, you have urban population density, but ultimately the bats getting closer to people is because the bats' original habitat had been destroyed. In places like Brazil and the Amazon, we know that as the forest edge increases, there's more probability of wildlife or vectors, in particular mosquitoes, getting, infecting people. And so there are other pathways through which deforestation, and there are lots of studies to this now. But it is absolutely true that if you, in the context of vector-borne disease, getting rid of all the mosquitoes is a loss of biological diversity. Which we did in the United States is one example. In other parts of the world, draining wetlands, we took out a large swath of biological diversity and reduced the burden of disease from things like malaria, in particular. And so it's not a one-to-one relationship.
I just want to remind everybody that they can use the Q&A tab to enter any questions. Ankish had asked, can you speak more on the relationship of the animal market trade, not just in China, but in the West, like New York City, and the consumption of meat for food to emerging diseases, both from air pollution perspectives, but water and land usage as well?
Okay. Before I get to that, Joe, I just want to mention that someone had asked about references around congenital defects and climate issues. I put one in, but there's a whole suite on particulate matter and heart defects. I put in one about heat and heart defects. And then, of course, there's evidence around particulate matter and birth outcomes, so preterm birth, low birth weight as well. So the issue of wildlife trade, many of you will recall that when in the early days of COVID-19, there were many folks saying we should just ban wet markets and we should nix the wildlife trade. And I suppose if those were possible, which I'm not sure they are, we can talk about why, that would even be a good idea because, of course, many people around the world, their primary source of subsistence, is particularly true of poor around the world, is wildlife. And so and there's been research done in places like Madagascar by my friend and colleague Chris Golden, who showed that if you actually enforced the regulations on consumption of wildlife among the poor of Madagascar, you would dramatically increase rates of iron deficiency anemia in young children, which, as we all know, has lifetime detrimental health effects. So, and then with, the wildlife trade, it's if you increasingly put pressure on that, it's going to drive it into the black market, making it yet harder to deal with. So these are tricky problems. Many people are surprised, and the question, I think, reflects knowledge that's quite deep about the United States. There are, in fact, live animal markets operating in the United States. There aren't many, and there's legislation in Congress right now to ban them outright. It's one thing to have a live animal market in a place like China. It's another thing in the United States. Now, interestingly, in China, the evidence suggests that the vast majority of demand for wildlife and markets these days is either for traditional medicinal purposes or out of curiosity. It's not subsistence. The Chinese to date are not going into the wilderness to get food by most accounts. So China has cracked down on this, but they've permitted continued consumption of wildlife trade internally to the country for medicinal purposes. You see very quickly the same issue that drives beef consumption in the United States, which is a cultural drive, is driving consumption of wildlife in China, the cultural drive for medicinal uses. And the issue there, of course, is that the Chinese population is huge, the wildlife populations are smaller. And so one of the things they've started to do is to farm these animals. So there are farms of civets, there are farms of other animals, to raise them specifically for the purpose of medicinal purposes. So that gets into this next part of the question is, what does this do to other sustainability outcomes, air pollution, water, so forth? Well, I think to the extent we know, and we don't know everything about wildlife trade by any means, I'm not sure there are major effects between wildlife trade and air pollution and water. I do think, however, that there are huge effects of livestock at a broader scale on those issues. And again, there's an equity piece of this because who wants to live near a foul-smelling, potentially chemically exposing industrial animal feedlot? Turns out not many people. And we also have seen, and there was I thought a particularly, an event that warranted particular attention from a disease emergence standpoint, which was the most recent H1N1 flu pandemic, which did not emerge in China. If you will recall, it emerged in Mexico. China has historically been the source of flu epidemics, viral strains, new viral strains, because of the confluence of species there and the historically large poultry and swine farms. And probably the reality that there are migratory birds that go up and down the Pacific Rim that introduce new flu viral strains into those breeding grounds for flu viruses to reassort and produce new strains. That's why the CDC goes to China every year to figure out what flu strains might appear to make a vaccine. When a flu strain emerges in Mexico, it begs and by the way, the town that it emerged in Mexico had the largest pig farm in Mexico. It really makes me wonder whether the advent of, huge livestock operations in different parts of the world is in fact making it harder to predict where the flu virus may come from and may increase the risk of flu emergence because it's, difficult enough with one major source of novel flu viruses in the world. But if we had multiple centers of flu virus emergence, that would make our lives much more difficult. And of course, those farms are huge emitters of pollution of all sorts. In the United States, by the way, pollution from agriculture, which this includes animal agriculture as well as crop-based agriculture, kills, I think the estimates were, it's certainly in the thousands. I want to say it might be around 12,000 people every year. That's largely from the air emissions that come from fertilizer use and burning of fossil fuels. And so there are real air pollution effects, particularly locally around these sites. We also know that livestock operations, particularly beef, consume huge volumes of water. I think, depends on how you look at the issue, but red meat in particular consumes huge amounts of water per kilogram of meat produced. I think that's a bit unfair because from a nutritional standpoint, we need to think about not just the weight of the product, but the nutritional content. And so a fair assessment would be in terms of the amount of, I would say not things like protein, but certainly about micronutrients or minerals like iron. That would be a fair assessment. But even on that scale, plants do somewhat better, although as you all know, getting iron out of plants, not the easiest thing to do in a diet. And there are real concerns about iron in particular in people in lower and middle income countries, and the fact that iron deficiency anemia is so common. So I hope that got most of the points of that question.
That's great. Peter, don't forget that you can just barge in anytime. Michael Miller from the American Medical Association is asking if most diseases emerge in the tropics and climate change means that subtropical regions will warm up and become tropical, then it seems we'll have a much larger and more populated area in which diseases will be emerging. Is that correct?
In one sense, yes, but in another sense, I have no idea. So I wrote a piece, I don't know, this is several years ago now, which was called Climate Change in the Crystal Ball of Disease Emergence. And the challenge is that while in the case of like vector-borne disease would be the most obvious instance, where mosquitoes, which had been prevented from living in certain places, are now, for example, there's some evidence that malaria is happening higher in the Andes, in the mountains of East Africa, because it's warming. The bigger signal is that what people do to combat these infections has been overwhelming in terms of the risk of those diseases emerging. Right, so the draining of wetlands, the spraying of insecticides, the anti-malarial drugs is a much stronger signal. From a public health standpoint, I think, before the COVID epidemic, I remember dealing with the measles outbreaks around the world and how disabling those were, even with relatively few people affected. And, when it comes to, as I was talking about, there's great panic in societies when new diseases emerge and people want things done, even when they're relatively uncommon. I remember the panic in the United States around Ebola, where we had almost no cases in the United States. So even if the probabilities are hard to pin down about something like dengue being established in the United States, which there's evidence that may be happening as we speak, it's going to cause huge disruptions. It's going to cause people to spend a lot of money to prevent those diseases. And then, of course, in places that have less money, it may, in fact, cause those diseases to really take root. Now, there are other diseases that are not vector-borne where I think it's even harder to figure out. So things like Ebola. Is there a chance that Ebola could develop a sort of urban cycle where someone's exposed to a bat somewhere in a forest, and then, we see these outbreaks in these major cities in Western Africa, whether that's in Nigeria, potentially Guinea, wherever. I think that's a major risk. I'm not sure how much climate will do that, because bats are, they move around a lot at baseline. They tend to tolerate a fairly large habitat, and the pace of climate change in terms of the landscape in which a bat might operate is relatively slow compared to, for example, deforestation or human population growth. And so the big picture I tend to think about, climate change as disease emergence is that, we're if we were gambling and we were playing roulette, which is the game we're playing here, except that when, we hit the right number, it's not good for us, it's bad for us. No one would choose to play this game of roulette if they really understood it, given that we have very little knowledge of the potential pathogens that might emerge. As I said, there's lots of viruses. It's just one group of pathogens out there that we estimate based upon relationships between what we've discovered and the small glimpses of viral diversity we've seen in various species. We know harbor viruses that can infect people like bats. And so the other side of it comes back to the points I made at the outset, which is if we know that preventing deforestation, as one example, is a critical part of climate action and preventing disease emergence, why wouldn't we do that anyway? And, as opposed to, the other, some people would say, well, we shouldn't act until we really understand whether climate change is going to cause more disease emergence. Of course, my response to that would be is by the time we understand that, the rest of the problems of climate change will be too late. And so we should forget about it. And, so there is a real tension right now between the public health and medical community around things like malaria. So the huge investments that have gone into curtailing malaria disease, which largely are bed nets, anti-malarials, and other very targeted interventions that deal with very, proximal causes of diseases, and things like climate change. Because some people are saying, well, you could spend all this money to educate folks, get all these things deployed, all this stuff, and then you don't deal with climate change, and all those investments go down the tube, right? And because there are new populations at risk, they have no immunity, they don't have the infrastructure to test and treat, all of these concerns, and then you sort of have to reinvent the wheel. And so part of the question is just things like the Global Fund is they spend nothing on climate-related risk or exploring that, and they're not mandated to, and yet all the money they're spending, the billions of dollars a year, which is desperately needed, it's not to say it isn't, it kind of begs the question, shouldn't we be thinking about the potential that those investments are going to have to shift, or at least use some of them to prepare for the likelihood that malaria, as one example, is probably going to become more common in East Africa. The model suggests that malaria in West Africa, it's going to be too hot. So the mosquitoes can't live there, but in East Africa, it's going to be more suitable. And so there are questions like that that are very much in play with climate change and emerging disease risk.
Are there any other questions? If there are, please stick them in the Q&A thing. Let me just say that we'll probably make this webinar available on the WMA website later, so that if you want to review it, you can. And go ahead, Peter. Did you want to say something?
Well, if there are no more questions, I wanted to riff off something that Ari just said about the malaria situation. It's a reinforcement to some degree of what I was saying before. One piece of the malaria fight has been the question of DDT and its use. That's an issue that we were involved in for many years because of its toxicity, excuse me, and efficacy in only certain selected situations. But it underlines the question of often these interventions are interventions forced upon us because of the dominant political situation in many countries. The threat becomes the same, but often the response can be a lot more economical if the government and the people are well coordinated within their perspectives in these countries, this means that that democracy is intimately associated with these questions, because countries that have eliminated malaria often have done it through mobilization of people, rather than the reliance on one or another drug or one or another intervention, such as, well, bed netting, very important, but it is obviously an intervention that is individually reliant. Anyway, just as a side effect from another issue at another time.
Just before we get to the question that was added, I just want to ask both of you guys, you touched on this very briefly, Aaron. the divestment of carbon producing stocks within organizations. Like, for example, in my case, the Massachusetts Medical Society, we're trying to move in that direction. I'm just wondering how important you think that is politically. And I am actually curious about organizations like Harvard with a huge endowment, what they're doing as far as divestment is concerned.
Yeah, so for those who may not be familiar, there's a movement afoot to have institutions divest from fossil fuel interests. So in the form of stocks and other holdings that they may own, selling those as a way to signify that these are what are called stranded assets, meaning that if you took climate change seriously, why would you be investing in the production of materials that are at the root cause of climate change? And so we've seen many institutions of higher education in the United States, foundations, and others divest, that they have made statements. And investment is not uniform. Some have said we're going to divest from coal. Some have said we're going to divest from all fossil fuels. How to do that is not entirely clear. But I would say two things to the bottom line. One is that there's no expectation that these actions of divestment are going to matter at all to the financial welfare of the companies that are being divested from. And that the main purpose of these actions is to signify the reality that we cannot rely on fossil fuels. It's a form of social protest. Harvard has not divested. There's been a very heated debate between various parts of the university on this issue. The medical school faculty recently voted to divest. The dean has not moved forward with that. The Harvard faculty more broadly voted to divest. The president of Harvard has not followed suit. And the dynamics of this, as one might imagine, are often, I think, shrouded from view. So my sense is that the argument put out by Harvard is that the endowment should not be used for political purposes. It should not be used to, make political statements. And of course, that doesn't hold much water, because that means that, where you put your money has no political value at all, which is absurd. And so we are making political statements all the time by where we choose to invest our money, and to, inaction being a sort of waiver on that doesn't make any sense. I think there's the action that says it's hypocritical. So that was one of the comments of the president, which is that how can we consume fossil fuels on the one hand and rely on them, and with the other hand, say these things are, not worthy of our investments. And, I think that may have slightly more water to hold as an argument, but at the same time, Harvard just pledged to be fossil fuel free by 2050. So we are, in fact, trying to get ourselves entirely off of fossil fuels. I think, though, at the end of the day, there is one part of divestment that bothers me a lot. And that's something I alluded to, which is that the reason we're not doing something, and we can focus on climate change, and I can focus on the United States because it's what I know best, but I think the dynamics here are frankly not much different than they might be in Australia or India, well, India is an interesting case of this, but the reality is that for people who care about climate change, divestment is not, it is a rallying cry, but it's not going to move the needle. It's going to, in my view, it's going to have the effect that an inconvenient truth did, which was it was somewhat empowering to, or potentially very empowering to, a small section of people who are already engaged on climate change. And to those who are not, it was alienating and confusing and bewildering. And particularly when we see organizations, and this is my personal view, like the American Medical Association, which has called for divestment, without actions that actually address some of the poorest, most vulnerable people in the country whose livelihoods depend upon those jobs, it strikes me as ethically unfounded. It strikes me as saying, it plays into the argument, which I think increasingly holds weight, that we don't actually care about those people. that in fact we think their livelihood should go away. And I know that's not in the heart what anyone who wants to divest wants, but it is in fact what those folks are hearing. And so I think it is too easy in some ways to divest without, frankly, putting the needs of people who are not aligned with us first. So those are my thoughts on divestment. And by the way, it could be a very don't get me wrong, it is symbolic, it can be powerful, but it can also profoundly backfire. And I think we have to do the calculation on that. There's a question here which I can answer around mosquitoes on entirely, in the Monty Python world, and now for something entirely different. So many of you will know that in the United States, we just released genetically modified mosquitoes to combat the emergence of vector-borne diseases. And this is something that's been percolating a long time, and it speaks to the adage of Oscar Wilde, which is the only way to deal with temptation is to succumb to it. And I think there's several important things to learn about this, right? So these mosquitoes, it's not new. People have been doing this for a long time in labs. The mosquitoes are designed essentially to kill themselves through genetic manipulation and wipe themselves out. So, and that would mean without the mosquitoes, these diseases can't be transmitted. So in principle, this is a way to get rid of mosquitoes that doesn't involve draining wetlands. It doesn't involve the use of insecticides. It doesn't involve, all kinds of other measures that have real adverse known consequences. And so the question is, what could possibly go wrong? And the answer is we can guess, but we don't know. And so the challenge becomes with something like introducing mosquitoes, it would be one thing if we had a bubble we could put them in and prevent them from touching anything outside the bubble. But of course, that ain't happening. And I do know for a fact that we as a species have a ridiculously terrible history of introducing species into places for the benefits of people. I mean, we've got anyone in Australia, anyone in any country in the world has probably been subject to this issue. And, we have everything from, kudzu in the United States to cane toads in Australia to, snakes in Hawaii and a bazillion other examples. And so the temptation has been, isn't this a great idea? Isn't this a great idea? And, it's happening. So we now are going to be stuck with what are the consequences of this? And so we can hope that it does what it's supposed to do, which is radically reduce the populations of these mosquitoes, and that does not result in untoward effects. But if there's anything you've learned, anything I've learned from studying ecosystems, which is there are no free lunches. You cannot take out a huge part of an ecosystem and expect it to have no effect. I mean, as a pediatrician, I remember when people were talking how great it was that, we were dealing with preventing Group B strep, which it was. Group B strep is a perinatal infection. It was a terrible thing. Children died. And the incidence was extraordinarily low. And so now in women who test positive in pregnancy, we give them all antibiotics. And that has prevented a large number of cases of Group B strep sepsis. But it's also caused a lot of disease. And we don't want to come to terms with that yet, but it is likely that the early administration of antibiotics is fundamentally changing the microbiome of children. And that is a part of the epidemic of diseases we're seeing related to immune dysfunction in the United States. And, there are certainly other causes to that too, but to presume that it is benign is not quite right. And the question becomes, can we do a better job of screening and limiting exposure to people who really need it? And I think that's the task that we haven't really gotten to very strongly. And so, I think our challenge now is to watch what happens with the mosquitoes. I might say that there's a parable in the mosquito story to the broader issue of climate change, which is the more our backs are put against the wall, the more climate change becomes intolerable, the more problems that may arise from emerging infections, the more attractive previously unattractive options become. No one would be talking about nuclear power right now if it weren't for climate change. And so we're talking about nuclear power, and very smart, well-educated, well-intentioned people are advocating strongly for nuclear power. And I happen to see their point of view pretty clearly, which is that If we're as concerned about climate change as we are, and we need no carbon energy sources, the bird in the hand is nuclear energy. We see it with geoengineering, which is the use of aerosols, particles, putting them in the atmosphere to cool off the planet. Doesn't take much thinking to realize how wrong that could go. Imagine that one nation decided unilaterally that it was too hot for its crop yields and put aerosols up in the atmosphere, which can persist for long periods of time. And that caused a famine in some other part of the world. That probably wouldn't work well for international relations. So, these options, which would not historically have seemed to be particularly savory, now become more compelling. And of course, and geoengineering is a great example, which is cheap and easy to do, and it exists. It is so tempting to use that as opposed to, for example, reducing the production of fossil fuels, which are the root cause, because that takes much more time, patience, energy, and investment. And yet even the most enthusiastic supporters of geoengineering are very clear that this is not a pathway to a sustainable future. This is simply this is stemming the bleeding. This is packing an abdomen that's bleeding out with bandages to save us while we can bide some time to do what we need to do otherwise. So I think we're in a point in history where these options are increasingly coming to the fore, and the risks of things going wrong are and the mosquitoes are a great example of that. Is it possible that these gene drives could get outside of the species? Seems unlikely, but do we really know? No. It would be, we have a problem with insect diversity, and I know many people don't like insects, but it turns out that, as Ed Wilson once said, ants could survive just fine with us forever, but if ants ceased to exist on the planet, our lives would end in the span of a few years. So, we can't really afford for experiments with the insect world to go wrong, and that's what we're doing. I think I'm cautiously optimistic that people have done the right experiments to figure out that the gene drives in these mosquitoes are not capable of going across species barriers. And so that's what we're hanging our hats on right now.
Peter?
Oh, good. This is getting into some good stuff. And without discussing the relative risks of fossil fuels, of nuclear fission, let me go back to the original concern you have about the demand for disinvestment in fossil fuels, because I was about to laud the WMA as well as the AMA for taking that position. Now, you point out rather clearly that it's not going to have an overall effect. But what you left out of that argument about why it won't have an effect is it's economically insane for people to be investing in fossil fuels today for the pure economy of projecting new coal-fired power plants versus other sources of energy today. But that's a whole other discussion and very interesting. We began this discussion, or I don't know if it was begun solely with us, but with the Harvard Corporation in 1963 about their investment in racial segregation in the South. And it has gone through several iterations since. The corporation always has the same position. You have to keep all of that separate because it is so hard to disinvest. Yes, absolutely. Not only hard, but probably impossible to disinvest in fossil fuels. You can make steps along that way. You can have your investment people say, we would prefer to go this equal thing rather than that. But there is such a, as you said earlier, there is such a penetration of all aspects of the economy with the fossil fuel production sector that disinvestment in reality becomes very difficult. But the bully pulpit of calling for that and placing it in the same position as cigarettes, tobacco smoke, and other investments such as arms for war, I think is a very important thing. And you will find no group that is advocating for this investment that does not talk about just transition. This is something that came out of the oil, chemical, and atomic workers 30 or 40 years ago. You must discuss how you want to handle people who are displaced in the economy. The only people who are not handling that and are not discussing that are the people in fossil fuels, or more particularly the petrochemical industry, that is just shifting their investment away with no accounting, as they do regularly, for people left behind in obsolete technologies and obsolete production processes. I had one other question for you. Leaving that alone for a moment, that I'm interested in your comment on, if it's possible. Is that okay, Joe? We got no more time.
Yeah, we have 2 minutes. Go ahead.
The only question I have, and 2 minutes I don't think is enough time, but the impact of climate change on Middle Eastern politics and the immigration pressure from the Middle East toward Europe, creating a political environment there that caused some countries like Spain and Italy, perhaps, being unable to handle the COVID-19 crisis. You got 3 words on that? Would be of interest.
Not really. That's 2.
How about how much reliance can be placed on computer models of predicted beneficial and harmful effects of intervention aimed to reduce climate change?
At a broad scale, it's hard, but in smaller scales, it's being done and increasingly better than it used to be. I think to Peter's question, climate change is certainly a driver of population migration. We've seen it already, and it's going to probably increase, and they feed off each other. Climate change sows political instability and poverty. That's a source for migration. The extreme weather events and cause people to move, and mass displacement of people is a cause of political instability. These are vicious cycles. And so I think whether it's in the context of disease spread, which, no one asked about HIV and the top burden of disease, but it turns out a major driver of HIV is population displacement. And so HIV is very much in play with population displacement. There's real risk to pandemics, there's real risk to instability, and without governance, it's hard to do stuff on climate change, turns out. So I think there's a really important, again, in the context of motivations to do something, it's, you can put Band-Aids all over it, but it really does require, in the case of pandemics, the primary prevention actions are clearly where the need is. And with climate change, we have to adapt because it's happening, but we can't afford to let that be the mainstay of response. And I don't think anyone is, or at least those who care are saying that. But I think that there's always the temptation that we can always engineer the climate or engineer our way out of it.
Okay, well, let me thank both Dr. Aaron Bernstein and Dr. Peter Orris for a terrific hour and a half. And I want to thank all of our attendees. And as I said, we'll probably put this webinar up on the WMA website later. And I hope you all have a wonderful rest of the week. Thank you very, very much.
Thank you, Joe.
Thank you.
Bye-bye, everybody.